Stephen Hawking famously stated that human beings are, well, nearly chemical scum on a very typical planet, orbiting an average star.
Right, in the outer suburbs of a very typical galaxy. It's a very cold and finite view of humanity.
Yeah, it really frames us as this temporary cosmic accident, you know? Just a biological virus completely irrelevant to the grand machinery of the universe.
Exactly. But the question is, what if that perspective is not just, slightly pessimistic, but structurally and mathematically wrong?
Right, what if human beings, and specifically the knowledge we create, are actually the center of the universe's potential?
Yeah, the only entities capable of infinite reach, the singular force with the capacity to literally shape the cosmos.
Okay, let's unpack this, because that is the ultimate tension in modern thought, right? We're caught between these two narratives.
We really are. One tells us we're a biological plague overrunning a fragile rock, defined entirely by our limits and our eventual extinction.
Yeah, the carbon footprint narrative.
Exactly. And the other narrative, which was pioneered by physicist David Deutsch, suggests we are the literal engines of reality itself.
Which is just a massive paradigm shift. If Deutsch is right, we have to completely overturn how we think about power, about resources, and global policy.
Not to mention the very nature of physical reality. But to understand how we could possess that kind of cosmic significance, we have to start at the bedrock.
Right, how we actually learn things.
Yeah. Because our current global institutions, from Wall Street algorithms to how we fund science, they're built on an assumption about knowledge that Deutsch argues is entirely false.
And that assumption is induction, right?
Yes, induction. And to understand the architecture of reality, we basically have to dismantle it.
So define induction for us.
Well, induction is this deeply ingrained idea that we derive universal truths just by repeatedly observing the same phenomena.
Like the belief that the future will resemble the past simply because it always has.
Precisely.
But, that sounds like pure common sense. You watch the sun rise every single morning. After 10,000 mornings, you conclude the sun will rise tomorrow.
It's incredibly seductive.
Right.
Because it mimics the feeling of learning.
Yeah, you drop a stone 100 times, it falls. You conclude gravity exists. How else would a society build knowledge?
Well, it feels rigorous, but induction is a fundamental epistemological trap. The traditional view suggests that if you just gather a large enough data set, the truth it reveals itself to you.
The data speaks for itself.
Right. But observation without a foundational explanation is entirely blind. What most people misunderstand is that repeated observation does not create new knowledge.
It just reinforces a statistical assumption.
Exactly. And the most striking way to illustrate this is Bertrand Russell's thought experiment, the Thanksgiving turkey.
Oh, right. The turkey on the breeding farm. Walk us through that.
So imagine this turkey. On day 1 of its life, the farmer comes out and feeds it. The turkey observes this. Day 2, the farmer feeds it again. The turkey, operating like a modern data scientist, starts to build a predictive model.
Right, taking in data points.
Yeah, day 10, day 100.
Yeah.
Every single data point confirms its theory.
So the turkey's inductive model is saying, the farmer is highly predictable and benevolent. His purpose is to give me grain.
Exactly. The turkey has a vast data set, massive statistical significance. And then the Wednesday before Thanksgiving arrives.
Oh.
Yeah. The farmer walks out, but this time he wrings the turkey's neck.
Wow.
In an absolute instant, the turkey's inductive model drops from near perfect historical accuracy to absolute zero.
Because the model failed. Not because it didn't have enough data, but because it didn't understand the underlying reality.
Precisely. It lacked an explanation of why it was being fed. It only had observations of what was happening.
It had no concept of human agriculture or holidays.
Right. And what's terrifying is that human institutions make the turkey's mistake constantly.
We really do. We look at a real estate market going up for a decade and just assume year 11 will be the same.
Until the 2008 subprime mortgage crisis hits.
Or we look at global supply chains working perfectly and assume free trade is just the default state of the world.
Exactly. Until a pandemic or regional war just shatters the illusion overnight, we act like the turkey on a Tuesday.
We confuse a trend with a law of physics.
Yes. And philosopher Karl Popper, whose work David Deutsch builds heavily on, pointed out that true science doesn't work via induction.
Right. Observation is passive.
Yeah. But knowledge creation is active. We derive theories through a highly specific process of conjecture and criticism.
Okay, let me challenge that right there. Because conjecture is just a polite word for guessing, isn't it?
Well, yes. It is guessing.
So if science is just guessing, isn't that intellectual anarchy? How is Einstein's relativity more valid than a fortune teller reading tea leaves?
It's a crucial distinction. It is guessing, but it's not unconstrained guessing. All knowledge begins as a bold leap of imagination to solve a specific problem.
Like observing an anomaly. Say, Mercury's orbit not matching Newton's laws.
Exactly. You can't observe your way to the answer. You have to imagine a new structure of reality. You conjecture a solution.
But then comes the second half, the criticism.
Right. You subject your guess to the most brutal, unforgiving tests possible. You try to falsify it against physical reality.
You try your hardest to destroy your own idea.
Yes. And the guesses that survive are what we tentatively call knowledge. But there's a strict architectural requirement here.
Which is?
It can't just be any story that fits the facts. It must be what Deutsch defines as a good explanation.
So what separates a good explanation from a bad one? If both the fortune teller and the physicist are guessing, what's the metric?
The defining metric is that a good explanation is hard to vary.
Hard to vary, meaning the details of the theory are locked into place.
Yes. Every single component must be tightly constrained. If you could arbitrarily change details without changing the predictions, it's a bad explanation.
Okay, let's ground this. Let's look at ancient civilizations explaining the seasons. They observed it got cold, crops died, then it got warm, crops grew.
Right, the observation.
And their conjecture, their guess, was the myth of Persephone. Hades kidnaps her, her mother Demeter gets sad, causing winter. Zeus negotiates her return, Demeter rejoices, and we get summer.
Now, objectively, that theory actually fits the observed facts perfectly. It predicts winter will follow summer.
But mathematically and philosophically, it's a terrible explanation.
Because it's entirely too easy to vary. You could swap the characters. It's not Persephone, it's the sun god needing sleep.
Or the gods punishing humanity.
Exactly. You change the mythology, and the prediction stays the exact same. The explanation is disconnected from the reality it describes.
Now, contrast that with the modern understanding, the Earth's axial tilt.
Right. The 23.5-degree tilt is a spectacularly good explanation because it is incredibly hard to vary.
If you change the angle even slightly, the whole theory shatters, right?
Instantly. Change it to 10 degrees, and your predictions about day length, severe seasons, shadows, they all fail. It's rigidly locked into physical reality.
It forces you to show your work. I mean, there's an example in the medical field that highlights this perfectly. The grass cure for the common cold.
Oh, right.
If I say eating exactly 1 kilogram of grass cures your cold, that's technically a testable theory. But it's a terrible explanation.
Because it lacks a restrictive mechanism.
Right.
If you eat the grass and still have a cold, I can just effortlessly vary the theory.
Right. I'll say, oh, you needed to eat 1.1 kilograms, or it has to be on a Tuesday.
Exactly. Because there's no underlying mechanism for why the grass cures the virus, I can just continuously move the goalposts.
Which we see in bad science, bad economic policy, and ideological dogma all the time.
Constantly. When a policy fails, the architects rarely admit the theory was wrong. They just vary the explanation. We didn't spend enough.
And this is why the pursuit of settled science is a contradiction, right?
Absolutely. Science is never settled. It's an infinite process of replacing good explanations with even better, harder to vary ones.
Like Newton to Einstein. Newton's gravity worked beautifully for planets.
But it wasn't final. Einstein's general relativity explained anomalies Newton couldn't handle. And Einstein didn't just stare at apples longer than Newton.
He didn't just gather more data. He made a massive creative leap of imagination.
He imagined a mechanism no human eye had ever observed space-time as a flexible fabric.
He created knowledge out of pure thought, then subjected it to the brutal criticism of physical observation.
Exactly. And this leads to a fascinating parallel. The universe has been using this exact epistemological framework long before human brains existed.
Which brings us to the second strand of Deutsch's framework, evolution.
This is where Deutsch's worldview really starts to reveal its scale. Darwinian evolution is practically identical to Popperian epistemology.
It's a mechanical process of conjecture and criticism.
Yes. In biology, a random genetic mutation is the guess, the conjecture. An organism is born with a slightly thicker coat of fur.
And then the environment provides the criticism.
Right. If the mutation is poorly adapted to the cold, the organism dies. The biological theory is falsified.
But if it's well adapted, it survives. And the knowledge in that DNA replicates.
Exactly. DNA is literally a storage medium for knowledge. A polar bear's genome contains hard-won knowledge about metabolizing seal fat.
That is a massive paradigm shift. We're taught survival of the fittest means physical dominance. But it's actually about the survival of the most accurate knowledge.
It is. But biological evolution is agonizingly slow. It requires millions of generations of literal death to trial and error its way to a solution.
It's totally blind. A species can't see an ice age coming and say, hey, let's start mutating thicker fur.
Right, and that severe limitation is what makes human beings qualitatively different from every other biological organism.
Because we don't have to wait for our genes to mutate to survive the cold.
No, we can conjecture the idea of a heavy coat. We can imagine fire. We can engineer central heating.
We abstract the evolutionary process out of our DNA and put it into our minds.
Exactly. We simulate the death of our ideas in our minds, rather than physically dying in the environment. This is mimetic evolution.
So humanity represents a fundamental escalation in the universe's ability to generate knowledge.
We are conscious problem solvers. And that bridges perfectly into the third strand, computation.
Yeah, let's talk about Alan Turing. How does computation prove that human exceptionalism is a mathematical reality?
Well, Turing mathematically proved that a universal computer can simulate the behavior of any other physical object or process in the universe.
Provided it has enough memory and time.
Right. Now, apply that to human biology. The brain is a physical object. It operates on chemistry and physics.
So it is a physical computer.
Yes, and because of its architecture, it is a universal computer, which leads to this staggering concept Deutsch calls the universal explainer.
I'm struggling with the absolute limit of this. Are you saying that because the brain is a universal computer, it's capable of understanding any physical process in the cosmos?
Yes, anything. Whether it's nuclear fusion in a star or a supermassive black hole. It's governed by physical laws, so our brains can simulate and understand those laws.
That shatters this popular idea that because we evolved on the savannah to throw spears, there must be deep mysteries of the cosmos beyond our comprehension.
Right, the idea that we're just dogs trying to understand calculus. It's intuitively appealing, but fundamentally misunderstands universality.
Our cognitive tool, the ability to create explanations, is universally applicable.
Exactly. Once you have a system capable of general-purpose knowledge creation, its reach is infinite.
It's like an alphabet. You invent 26 letters to record grain shipments, but you can use those same letters to write quantum mechanics equations.
Precisely. If alien physics exist, they can be computed. And if they can be computed, they can be understood by us.
Let me push back on this reliance on the physical brain, though, because this leads to a massive debate about mathematics.
Okay, let's hear it.
We tend to put math on a pedestal. Absolute, unassailable truth that exists independently of the physical world. How does this physical framework handle the purity of math?
It strips away the Platonic mysticism completely. Deutsch calls this the mathematician's misconception.
The belief that math is immune to the physical world.
Right. But ask yourself, how does a mathematician actually do math?
They use a brain, or computer, or chalk.
Exactly. Physical systems. And physical systems are subject to thermodynamics, quantum fluctuations, hardware degradation, and simple human error.
So because the instrument doing the math is physical, the math itself is a physical process.
You cannot separate the computation from the computer.
Yeah.
Therefore, math is an act of physical reality.
Wow. So can we ever claim absolute 100% certainty about a mathematical proof?
Well, strictly speaking, no. Mathematics is an act of creative, fallible conjecture. Even our foundational axioms can be overturned.
I need an example of that. Telling someone that 2 + 2 = 4 is a fallible conjecture sounds absurd. Give me an absolute mathematical certainty that was shattered.
Euclidean geometry. For 2,000 years, it was the gold standard of absolute mathematical truth.
Right.
One of its axioms is intuitively obvious. Between any 2 points, you can draw one and only one unique straight line.
Seems undeniably true. Put 2 dots on paper, there's only one straight path.
But notice the assumption. You assume the paper is perfectly flat.
Right. Oh, I see where this is going.
Wrap that paper around a curved 3D surface, like a globe. The axiom shatters. A straight line behaves differently on a sphere.
And if you move through 3D space, you can punch a hole straight through the interior of the globe, a completely different straight line.
Exactly. The geometry of curved space rewrote what was considered mathematically settled. The math only worked because they misunderstood the physical space.
And that realization is what allowed Einstein to formulate general relativity. He realized space-time itself is curved.
Precisely. Once the physical understanding changed, the mathematical absolute had to be thrown out.
That is incredible. Even math is an ongoing attempt to map reality.
It really is.
You know, if you are listening to this and finding value in these kinds of dense, fundamental breakdowns, Consider subscribing to the Deep Dive. We tackle these foundational concepts every single time.
We do.
Now, let's move into the deepest waters. We've established human knowledge is infinite, mirroring evolution and computation. But what about the physical reality where this computation happens? Let's talk quantum mechanics.
Here's where we transition to the actual architecture of the universe. And in quantum mechanics, everyday intuitions just break down completely.
Here's where it gets really interesting. For a century, quantum physics has been treated like mysticism. Schrodinger's cat, things in two places at once.
Right. The subatomic world is just seen as illogical. But Deutsch champions a fiercely rational interpretation. Hugh Everett's many worlds interpretation.
Walk us through the famous double-slit experiment step by step, because that anomaly unlocks the multiverse.
Okay, let's start with the baseline expectation. Imagine a solid wall with two narrow vertical slits. Behind that wall is a projection screen.
Okay, wall with two gaps, screen behind it.
Now, imagine a cannon firing tennis balls dipped in paint at the wall. Most bounce off. But the ones that pass through the slits travel in a straight line and hit the screen.
So if you fire 1,000 balls, you get two neat vertical clusters of paint on the screen.
Exactly. Basic Newtonian physics. Particles travel in straight lines. Now, change the medium. Instead of particles, submerge the setup in water and generate a wave.
Okay, a continuous wave hitting the two slits.
When the wave hits the wall, it squeezes through both slits simultaneously. It emerges on the other side as two overlapping ripples.
Like dropping two pebbles in a pond.
Right, and where those ripples overlap, they interact. Crest meets crest, they amplify. Crest meets trough, they cancel each other out.
And when that overlapping wave hits the screen,
it doesn't leave two neat clusters. It leaves an interference pattern, a series of alternating high-intensity and zero-intensity stripes.
So particles create two neat clusters. Waves create a multi-striped interference pattern.
Exactly. Thomas Young did this with light in the 1800s, saw the stripes, and physicists concluded light is a wave. Case closed.
But then the 20th century rolls around.
Right, and they discovered the photoelectric effect. Light is actually quantized. It's made of discrete particles called photons, tiny bullets.
And if light is bullets, it should act like the tennis balls.
Exactly. So they set up a precise experiment. They fire a single photon, one indivisible particle of light, at the slits, one at a time.
Logic says a single particle must pass through either the left slit or the right slit. It can't split.
Right. So if you fire millions, one by one, they should slowly build up two neat clusters on the screen.
But they don't.
They do not. Even fired completely isolated, they land in an erratic distribution.
Yeah.
And over time, those single dots slowly build up that exact same multi-striped interference pattern.
Hold on. This is where the brain short circuits. If you fire a single particle through the left slit, it should travel in a straight line.
It should.
The only way it deviates to form that wave pattern is if something physically pushes it off course. But it's the only particle in the vacuum chamber. How is it interfering with itself?
In a single universe, it is not physically possible. It's a logical contradiction.
And the traditional response, the Copenhagen interpretation, basically just abandons realism.
Yeah, it says the photon doesn't exist as a solid particle until you look at it. It exists as a wave of probabilities passing through both slits magically.
And only when a conscious observer measures it does the wave instantaneously collapse into a single particle.
Right. It's a massive evasion of good explanation. It abandons continuous physical history.
Which brings us to Hugh Everett and David Deutsch. What is the actual mechanistic explanation for why that single photon is deflected?
Everett just took the math seriously. The Schrödinger equation doesn't contain any term for a wave function collapse. That's an arbitrary rule bolted on.
So if you don't collapse the wave, what does the math say?
It says the wave continues. The only logical explanation that obeys the equations without mystical collapses is the multiverse.
Wow.
When you fire that single photon in our universe, it is not traveling alone.
What is it traveling with?
It's interacting with unseen photons in parallel universes. The physical universe we observe is just one slice of a vastly larger quantum reality.
So when the photon is fired, the multiverse differentiates. Our photon goes left, but a counterpart photon in a parallel universe goes right.
Exactly. And because these universes overlap at the quantum level, the photon we can see literally bounces off the photon we cannot see.
That subatomic collision is what deflects our photon and causes the interference pattern?
Yes. The interference pattern is literally the physical shadow of parallel universes bleeding into ours. We are seeing tangible evidence of the multiverse.
That is just staggering. If we take the multiverse as a given, how does this connect back to epistemology and evolution?
Well, let's look at knowledge creation across the multiverse. We know it happens through variation and selection guessing and criticism.
Right, the scientist guessing or the gene mutating.
Imagine Einstein working out space-time, or a population evolving an immune system. In a quantum multiverse, every physical interaction branches into parallel histories.
So there are universes where Einstein drinks tea, and ones where he drinks coffee.
And crucially, branches where he makes a math error, and branches where he doesn't. Now think about errors versus truth.
Errors are random. There are infinite ways to get a math equation wrong.
Yes, so across the multiverse, errors diverge. The Einsteins who make mistakes will all make different random mistakes, leading to countless dead ends.
But the truth, the good explanation, is singular and robust.
Exactly. The versions of Einstein who successfully navigate the math will all arrive at the exact same universally true equations for general relativity.
Because the truth works in every universe where the physics are the same.
Precisely. Therefore, true knowledge literally replicates itself across parallel universes. It forms a robust multi-universal structure.
Deutsch calls this a crystal of truth embedded in the multiverse.
A crystal stretching across parallel realities, yes. The closer an idea is to objective truth, the more heavily it's represented.
That is a staggering visual, and it brings us to this massive realization about human agency. We aren't passive observers. We are a literal force of nature.
Right. If you look at the universe through a classical lens, you can explain almost everything with basic physics.
Like an alien pointing a telescope at the Milky Way.
They don't need philosophy to explain the galaxy's shape. Gravity and thermodynamics explain it perfectly. Matter interacting blindly.
But what happens when they zoom in on Earth, say, on Manhattan?
Classical physics fails completely. Gravity didn't pull refined steel and glass into the Empire State Building. Thermodynamics didn't design the electrical grid.
To explain Manhattan, they must factor in human knowledge.
You have to invoke epistemology. Conscious humans recognized a problem, imagined a solution, criticized the engineering, and transformed raw earth materials.
Human knowledge overpowered the baseline state of nature. Left alone, nature just leaves rock and water there.
In this localized area, the dominant physical force is human epistemology. People are a force of nature reshaping the universe into highly ordered states.
Which brings us to the future trajectory. Because this completely destroys the dominant modern narrative governing global policy, the Malthusian trap.
Oh, absolutely. The Malthusian trap is the source of profound global anxiety. The idea that we're a biological plague destined to run out of scarce resources.
We're constantly told we're running out of oil, rare earth metals, arable land. Where did this idea originate, and why is it so mathematically flawed?
It originated with Thomas Malthus in the 18th century. He observed that population grows exponentially, but food production only grows linearly.
So eventually we starve. The logic seems sound. Why was he wrong?
Because his model assumed human knowledge is static. He looked at 1798 farming techniques and assumed they were the final limit of human ingenuity.
He didn't predict the tractor or artificial fertilizers?
Or genetic modification.
Yeah.
He treated humans like bacteria in a petri dish. If bacteria run out of sugar, they die. They can't invent a new way to synthesize calories.
Exactly. And the modern doom narrative makes the same error. It assumes resources are a fixed objective category in nature.
But resources don't exist in nature. The universe only contains matter and energy. It's human knowledge that transforms matter into a resource.
Uranium wasn't a resource to the Romans. It was a useless rock until we discovered nuclear fission.
The parable of europium illustrates this perfectly. During the early color television boom, screens used cathode ray tubes. To get the color red, they needed europium.
And economists looked at TV sales, compared it to global europium reserves, and panicked.
They built peer-reviewed models proving the Earth would soon run out. In a narrow physical sense, they were right. Europium is scarce.
But we didn't run out of televisions. We have more screens than people now.
Because human creativity intervened. We invented liquid crystal displays, LCDs, then plasma screens, then OLEDs. We completely bypassed the need for europium.
We solved the problem not by rationing it, but by making it obsolete.
Exactly. Wealth isn't a barrel of oil or a vein of lithium. Wealth is the set of physical transformations we are capable of effecting.
And since our capacity to create knowledge is infinite, our resources are practically infinite.
This turns the Malthusian paradigm on its head. In their view, every human born is a liability, a carbon footprint.
But in Deutsch's framework, every human brain is a universal explainer, a lottery ticket for a fundamental breakthrough.
Right. When we suppress population or restrict freedom out of fear of scarcity, we're destroying the very engines of innovation that solve scarcity.
That is such an optimistic pivot. Let's push this to the absolute extreme. The Fermi paradox. Where is all the alien life?
Right.
Stephen Hawking warned against broadcasting our location, saying advanced aliens might act like conquistadors and strip mine Earth for water or coal.
Hawking was brilliant, but his reasoning here was trapped in that primitive Malthusian paradigm. Under Deutsch's framework, that fear is illogical.
Break that down. A thriving alien civilization needs massive amounts of energy. Why wouldn't they want our resources?
Think about the prerequisites for interstellar travel. Any alien civilization that can traverse light years already possesses a mastery of physics that makes our tech look like stone tools.
Right, if they can bend space-time, they aren't hurting for basic commodities.
They wouldn't need our coal. They can flawlessly synthesize anything at an atomic level. They can build Dyson spheres around their star for infinite energy.
Or sweep up ambient hydrogen in deep space for fusion.
Exactly. It would be insanely inefficient to drop into Earth's gravity well, fight a war, haul physical water out of our atmosphere, and transport it across the galaxy.
When they can just effortlessly synthesize it from ice comets in deep space.
Right. So Earth's physical mass is completely useless to them economically.
Is there anything Earth possesses that an advanced alien civilization would actually value?
Yes. There is literally only one thing in the physical universe they could not easily synthesize on their own.
And that is?
New ideas. Unpredictable knowledge. Because knowledge is created through deeply localized creative leaps facing unique problems, our knowledge is distinct.
Our art, our philosophy, our scientific models, that's our cosmic currency.
Exactly. They wouldn't arrive as conquistadors. They'd arrive as tourists or data brokers. They'd come for our libraries, not our oceans.
Plus, to survive long enough to become an interstellar species, they must survive their own technological adolescence, right?
Right. They have to survive inventing nukes and AI. To do that, they must build a society that values error correction, nonviolence, and open inquiry.
An advanced civilization will necessarily be an enlightened one. They wouldn't see us as prey.
They will recognize us as fellow universal explainers. They'll want to trade ideas, because trading information mathematically accelerates knowledge for both species.
That completely reframes our place in the cosmic dark, and it leads to Deutsch's most important conclusion, the principle of optimism.
Yes, and it's frequently misunderstood. It's not blind hope or toxic positivity. It's a strict epistemological stance. All evils are caused by insufficient knowledge.
Therefore, all problems are soluble.
Assuming they are not explicitly forbidden by the fundamental laws of physics, if it's physically possible for atoms to be arranged to solve a problem, we can eventually figure out how.
So success is guaranteed if we keep learning. But what guarantees failure? What holds humanity back?
What holds us back are anti-rational memes, ideas or cultural structures that actively prevent conjecture and criticism, systems designed to halt error correction.
Give me an example of an anti-rational meme.
Authoritarian regimes. A dictatorship that crushes free speech and dictates state-approved science ensures that economic failures can never be publicly criticized and therefore never fixed.
But these exist in open societies too, right?
Oh, they are pervasive. Rigid educational systems prioritizing rote memorization over problem solving. Dogmatic political tribalism that punishes dissenting questions.
Any system that says the science is settled, do not question this.
Exactly. That artificially freezes the growth of knowledge.
I think that's the most urgent takeaway for everyone listening right now. What do you think is the biggest anti-rational meme operating in society today? Drop a comment and let's debate it, because recognizing these traps is the first step to escaping them.
Escaping them is our moral imperative. Morality is fundamentally about keeping the channels of error correction open.
So what does this all mean for you? Well, let's bring this all the way back to the beginning. We started looking at humanity through Stephen Hawking's lens of reductionist despair.
Right, as chemical scum on a typical rock.
But layer by layer, through epistemology, evolution, computation, and the quantum multiverse, we've dismantled that. You are a universal explainer living at the beginning of infinity.
Navigating a branching multiverse where your creative guesses and courage to face criticism are the literal engines driving physical reality forward.
Your capacity to learn is unbound by anything other than the laws of physics. It's incredibly empowering, but it carries responsibility.
The universe isn't a static machine we're trapped inside. It's a dynamic computational environment waiting to be transformed.
And that leaves us with one final unresolved thread to ponder: the true definition of free will.
Free will is often debated as a mystical concept, or denied by determinists. But in Deutsch's framework, it is the ultimate mechanical consequence of being a knowledge creator.
Think back to Albert Einstein inventing general relativity. He observed problem and guessed the solution.
But that specific knowledge, the complex math describing space-time curvature, was not implicit in the Big Bang.
It wasn't hidden in the baseline atoms of his brain waiting to unfold mechanically.
Exactly. It was entirely novel. It did not exist anywhere in the universe until the exact moment he consciously created it out of nothing.
Through a genuine, unpredictable act of creative conjecture.
And that knowledge altered human history. We rearranged metals to build GPS satellites because of it. We changed the distribution of matter on Earth.
That act bringing entirely new, universe-altering knowledge into existence is the quintessential act of free will. You are not a victim of the cosmos, you are its author. Your choices matter on a universal scale. Thank you for taking this deep dive with us. Keep questioning, keep criticizing, and keep creating. We'll see you next time.